Like she said, I'm Alex Wise. Thanks for coming to my talk. It's called No Time to Do It All. It's about those times on a software team where there's just more work happening than you can really get done, some thoughts about why that happens, and hopefully some tricks you might be able to take home to make that better, maybe. You can find me on social media at AWS Architect, most places. Love chatting with people there. Been a software engineer focused on reliability for a long time, small startups to large enterprises, everything in between. That's my dog, Clover. He loves responding to incidents too, but only when the incident is dropping food on the floor. Everywhere I've been, all these different places I've worked, I regularly see or encounter or am on teams where there's just more work coming in than we can really perform in time, and we're having to make these difficult trade-offs about quality, about timing, about working weekends, nights, things like that. The literature calls this state overload. I just know it as being busy. Just like quick clap if you have ever experienced being busy on a software team. Yeah, okay, cool. I mean, I tricked you to clap for me. That makes me feel good. But yeah, I think it's really common, right? And it's not just uncomfortable. It's not just frustrating. It can really have a detrimental impact if we stay in this mode for too long. So this is an article from the CrowdStrike incident from last year. It's come up at a few different talks this year. And it really just points to kind of the common production pressures that we see everyone in here has experienced, right? The pressure to ship, hard trade-offs about quality versus fixing interrupt work, things like that. So it's very common, and this state of overload is also can be pretty bad to stay if you stay in it for too long. So I really wanted to dig into kind of why it happens, and maybe hopefully figure out some things about can we make it better? So it started where all quests for knowledge start in the modern age. I Googled it. I was hoping that some AI oracle would come down and hand me like a 10-point listicle that I could follow and never be busy again. Not there yet. Maybe with GPT-5, we'll see. So then I went to the library. I'm really bad at libraries. I don't know about you guys, but I tend to like opportunistically browse and pull things off the shelves. I'll go in looking for books on system safety and come out with like a big stack of books on cat behavior. It doesn't work for me. So I thought, well, if I can't find the answers out in the world, maybe I can just reflect on my own experience as a software engineer and think about that and maybe come up with something. And I'm from Denver. We got a lot of great mountains there, so I'm going to walk up a mountain, I'm going to stay up there, and I'm going to think about this busyness problem, this overload problem, and I'm not going to come down until I figured something out. And I did that. And I think I discovered these two fundamental truths about the world, and I want to share them with you for the first time here today. You can call them Alex's truths. The first is that resources are finite, that our time, money, effort, attention, we don't have unlimited of that. The next is that change continues, that the world is moving around us and shifting things, and we have to adapt and respond to that. And I thought, yes, this will be my big contribution to this problem of overload. I don't know if he climbs mountains too, but we found out yesterday morning that this is Dr. Woods, that this is the theory of graceful extensibility. It's his adaptive universe. And it says just that, right? That as the world changes around us and we have to adapt to this world, that we will inevitably bump up against this time, resource, attention, effort limits that we have. And it will feel uncomfortable. We will not have enough stuff to respond to it. We will be in this state of overload. And I wanted to begin the talk with this because I think when we talk about things like technical debt, but also things like outages, particularly outages that kind of escape containment of this engineering world that we live in and have a real human impact, we get this chorus of this no true Scotsman kind of thing, like, oh, a real engineer would never ship code with no tests, or, oh, they knew about that bug for months and never fixed it, how dare they, or or the greedy business deliberately withheld reinvestment, knowing that it would cause an outage like this. And the thing is, if you believe in the adaptive universe, if you believe that this is a temporary natural order, that these systems will sometimes find themselves in the state of overload, then none of these need to be true. That really we should first and foremost have empathy for teams that are experiencing this kind of overload, because we will be there someday soon. I think it's also a really good argument for why we need to be efficient with the resources we have, even when we have enough of them, even when we have enough time, even when we have enough money, because we don't know when the world is going to change, and we're going to need to adapt, and we want to spend those resources wisely to get out of that state of overload more quickly. So I really liked Dr. Wood's, that theory really helped me feel better about the state of business. It's not just me being a slow coder that is why I'm seeing this so often. It's not me just being bad at my job and causing all this problem. That really is just a natural state of systems. But it didn't give me everything I needed, right? I think it was Tom DeMarco that said that software development is an act of discovery. And so things regularly feel uncertain. We're facing uncertainty, and often stuff is hard. So how do I know when the pain that I'm feeling is from this state of overload and not from some other cause that has other remedies? So Dr. Woods has this covered there too. This is the Patterns in CSE book. It is the applied companion to the Cognitive Systems Engineering book. If this group is familiar with the SRE book and the SRE workbook, this is like that applied workbook style book. And in it, he lays out a framework for how there are 4 possible responses to a system when encountering overload. If you saw Corey's talk, he also talks about this. We don't let you leave SREcon until you've memorized these 4 things. So pay attention if you've got a flight later. With the 4 ways that a system can react. It can shed load, it cannot do the work. It can reduce thoroughness, it can do a crappy job. It can shift work in time, it can do it later, or it can recruit resources, it can bring in things to help. And as a rule of thumb, those last 2, shift work in time, recruit resources, those tend to yield more positive outcomes in our systems. They do require anticipation, they require planning, they require cost and resources. And I love this framework. I think this framework is super cool. I like it in like a post-incident context. If you're in an incident interview and you start hearing things like, then the database had dirty writes, or that's when the web server was dropping requests on the ground. This framework can prime you, and you can think, okay, is there a way that we might adapt that part of the system to move from these kind of reactive responses to overload to maybe more proactive ones? Can we add back pressure? Can we enable auto-scaling? So I think that's super useful there. But the joint and joint cognitive systems refers to any system where we have humans and machines. So it holds true for like your incident response team and the web servers, but it's also true of your software delivery team and the Jira work queue that they work out of. So if we hear things like this one-off, it could be just a one-off poor communication or something. If you start to form a pattern, if you hear, hey, why did this change not get committed? Or we thought we said we were going to fix this months ago. Did that never get done? That could be an indicator that the team is responding to overload. By the same token, I think it is really important to celebrate when our teams do use these positive anticipatory planning-based responses. So like, hey, we don't think we're going to be able to get this done this quarter. Can we get this moved to next quarter? Or hey, we're a little busy with this to do all of this right now. Can this other team help with maybe this part of it? We should celebrate those because that is the system responding in the most productive way to being faced with more work than it can do. So I think I promise I am done poorly citing Dr. Woods at a conference where you can just walk out into the hallway and talk to him. I think. You never know with SREcon. I might have some other quotes hidden in there. But that was really helpful for me, right, to understand not only like why this is so common, but also, you know, when I'm in this mode, can I identify when my team was responding to overload. But the other thing I wanted to know was kind of, is there something that I'm doing that's making it worse, or is there something that I could be doing to put the positive spin on it that makes this state of overload better, that helps us get out of this state of overload, this mode of overload more quickly? And I'm an engineer, nominally. I like math, and I know a little bit about software engineering, so I thought, well, what if I make a little toy simulation of a software team and just kind of play with the inputs and outputs and see what happens? So we're going to keep it very small. We're just going to model a single service. It's just going to be 4 software engineers, all equivalent, all contributing equally. We're going to start by saying we're going to write 150,000 lines of code in year 1, and then we're never going to touch it again. None of us would ever do that, right? But we're not going to model like any kind of like feature ads or customer feedback or anything. We will model attrition. We want to say, you know, every year the employee that's been there the longest is going to rotate out. Just a very simple model of attrition. And we're writing software, so we do have to measure bugs, right? So for every X number of bugs that we have, or every X number of lines in the code base, we're going to find a bug. In this case, a bug, we're just going to randomly pick a single line of code and say, there's the bug, that's the bug. If the author, the most recent author of that line of code is still at the company, it's going to take 1 hour to fix. If the author is not there, it's going to take 10 hours to fix, but then they become the new owner of that line of code. All right, and the thing we're measuring here, like, I'm not trying to get to an actual number or like real quantitative value of any of this. I really just want to see the shape of the curve and kind of understand the inputs playing on it. And the thing we're going to measure here, we're going to have years by hours spent fixing this fixed number of bugs. So what does that look like? And I will email these. When I email these slides, I'll have like a detailed explanation in the speaker notes there. Hope that's helpful. But to talk through this graph here, in year 0, we're really cooking, right? We've written all of our code. We also have these bugs because that happens every time you write code. But we have high context, and we know about every line of code. We can fix it all really quickly. Over on the right, years 4, 5, and 6, things are a mess. We spend 15,000 hours a year fixing this code, but it's at least consistent, right? We know that when we wade into this mess, that it's going to take a long time. It's going to be pleasant, and we don't want to do it very often. But it's kind of here in that rise in years 1, 2, 3, where year after year, the same amount of work is taking longer and longer. We're bumping up against these limits of the adaptive universe. Things feel tough. This is where I think we feel overload most acutely there. But we don't have unbounded time to fix bugs in small services. So what happens if we say, you know, year 0 there, we spend 1,500 hours fixing these bugs. Let's just cap it there. That's all we're willing to spend. Well, as you might expect, the number of bugs you fix goes down a lot there because you're capping it, but also your backlog just kind of grows indefinitely. It's monotonic growth. Has anyone experienced just the endless growing backlog of Jira tickets? Yeah. Not super uncommon. So I don't know if there is a fancy academic term for this. I don't know of one. I would love a pointer to one if there is one. I call it knowledge decay. The idea is that as your knowledge of the system and how it works degrades, your facility at adapting it to the changing world changes, impacts your resilience. Things tend to freeze up. And given the economics of how software is built, I think we encounter this more often than we would want to. So that's how it is. What can we do about it? And when I talk to folks at meetups and at work and things, there's always this kind of immediate response. It's like, well, duh, Alex, you got to retain your employees. If you just didn't lose those employees, you would be in superstar mode the whole time. And I think that's super true, right? Retain your employees is a superpower. Do everything you can to do it, whatever your comparative advantage is there. If it's money, if it's freedom, if it's vibes, like do what you can to keep your employees for sure. It's not always possible, right? The folks who like to build from 0 to 1 rarely like the ride from 1 to 2 or whatever. And unless your company is in some kind of time bubble in 2018, there's probably not room on your ladder for everyone who wants to be promoted above senior to do so. So you can't retain everyone. You have to build robustness to people leaving the company. I think that's also a superpower. But what can we really do to do that? Well, let's take another look at that graph. There was kind of a buried assumption here. I said that each bug was represented by a single line of code, but also each line of code is represented by a single author. And in software development, that doesn't have to be true, right? We have tools. We have pair programming, mobbing, and the like, where you can have multiple people having context about a single line of code. So what does it look like if we were to pair program on this service whenever we touch it? Well, curve looks a little something like this, and I'll talk through it too. So start off in the same place in year 0, but we're completely robust to losing an engineer in year 1. There's still full knowledge of the code base. And really, like, our curve looks much better in years 2 and 3. It's not until we fully rotate all of those original authors off that we kind of shoot back up to where we were in our solo coding paradigm. An interesting thing to point out here too, I think, is like the impact of pair programming only exists at the point in time when you're actually touching the code. If you were to start pairing over in like year 6, when you're only touching a handful of lines of bugs every year, it's not really going to have that much of an impact. But that's also a choice in our model too, right? We can choose to change this code base after we touch it. Like let's say, for example, this is like an old 3-tier web service that's got some weird clunky data model trying to do transactions, and hey, the company moved to event buses after we wrote it. What if we just kind of put this on Kafka? We can keep the business logic the same, but it's writing to Kafka, which is going to have a bunch of benefits for us downstream. But what happens there if in like year 4 or 5 we rewrite half of the application? What does that look like? Well, it looks like this, where in year 4 we've got our normal 15,000 hours a year of fixing bugs, but then we rewrite half the code base, and that shoots back down to 8,000. We really reset the clock on the staleness of this code base and our facility with it. And it was when I got to this point, and I stared at this a while, I was like, oh man, that reminds me of something. I've seen something like that before. What is that? And it digging through bookmarks and trying to find it. This is a diagram from a blog post from Will Larson's blog. Will Larson, the CTO of Carta. Title of the blog is Migrations, the Sole Scalable Fix to Tech Debt. And in it, he makes the argument that really the only way to get your hands around and stay atop of the software and the infrastructure that you run of your system is to proactively seek out and fight for chances to migrate and update and refresh parts of the code base. If you just wait for things to become so broken they have to be replaced, you're constantly going to be firefighting. So it's a great blog post. I recommend everyone read it, but he's making the case there to proactively seek out migrations. And I just, to add on there, to riff on what he's saying, to yes and him, and migration is not just getting good at migrations. It's not just one thing. It's a whole set of muscles that you really need to build and deliberately work on in your organization. It's things like, how do you identify what would be a good thing to migrate? It's this idea that instead of asking, well, how does this work? You ask, if we were to rewrite this tomorrow, what would it need to do? That question tends to yield much more actionable answers. The building consensus thing. So how do you go from, oh, I think we need to rewrite this backend? Do we actually do the port to Kafka that we were talking about, or maybe we just like swap the end of life SQL Server for a new Postgres or something and call it a day? How do you build consensus about what actually you're going to do. De-risking is another part of this. Can you make the changes smaller? Can you do it in phases? Can you do it without customer impact? Do you need to talk to customers about what you're doing? I promise if you have a big migration go sideways, you're going to be migrating less than you want to or need to in the future. And I think most importantly is getting good at selling this kind of change to the business. If you just do a simple dollars in, dollars out analysis, the unfortunate truth is that you can get a lot of value out of just throwing burnt out on-call engineers and Band-Aid patches at a service to keep it running until something else happens. So what context are you framing this change in, and how are you making it something that's legible that the business should be doing? The other thing that happens at systems that struggle with knowledge decay, people who are, you might say, too online would call this Copenhagen culpability, but I find that no one knows what that means. So I like to call it you touch it, you own it-ism. Basically, the idea is if there is something that is not well understood in the organization and you go and touch it, and something happens later down the road, you bear some kind of ownership or responsibility for the thing that happened, even if you weren't directly responsible. So in places where that struggle with knowledge decay, there tends to be this kind of, oh, I don't see that. I don't want to see that. And that kind of behavior can lead to a kind of a great sucking sound of the knowledge of how your system works out the doors, because we really do, like Larson was arguing, need to proactively refresh our knowledge of how things work. So what do you do to fix this? Well, something that's probably necessary but not sufficient is to make sure things actually have ownership. You actually say, hey, you're responsible for this thing. I think by itself, you've still kind of siloed that knowledge. You haven't really empowered anyone to update or change or fix it. And like we showed in the pair programming graph, it's really a lot harder to get knowledge about a system shared around after it's been written and it's not being touched anymore. That's a really difficult thing to do. So one thing I like here is lunch and learns. You can just, it sounds like we don't know how this thing works. Can you go talk to this VP, read this old crusty documentation and kind of give us an explainer to everyone and share that knowledge out and make it okay to touch. Figure out your reward systems for this. Like, there's a lot of work in getting past this kind of Copenhagen culpability, this you touch it, you own it stuff. There's a story from Twitter days. I think Dan Liu, it was a tweet thread where he talks about the project to understand the health of the Twitter servers. And doing so required collecting, decoding, and organizing hundreds of thousands of undocumented message logs and figuring out what they meant and which ones were important. And that's not a thing that a lot of organizations typically reward, but can have a super big impact. If you're a solver style kind of staff engineer, I really like grabbing juniors by the hand and just diving into a part of the code base on a Friday afternoon and kind of building understanding and scaffolding back up. And as a principal or staff engineer, you're actually on the hook for all of these really hard things about migrations. I'm sorry, if it was easy, they wouldn't pay you so much. So that's my thoughts on knowledge decay. Retain employees however you can. Mob, pair, and share at the time of writing code. Proactively migrate everything that you can, and that you touch unionism. Don't let people try to avoid the poorly understood parts of the system. All right, so I like that. That helped. But this graph here, this ever-increasing backlog, also rang some bells for me. Maybe a decade ago, a head of product that I worked with really lent me a book. I never gave the book back. I liked it so much, so I'm sorry for stealing your book. This is Flow by Don Reinertsen. Don Reinertsen, you could call him like a systems thinker. He was one of the folks that was applying lean manufacturing principles to the work of software engineering. And he has a lot of cool insights. His big thing was he modeled software teams as mathematical queues, these kind of MM1 queues that had a certain set of properties that he thought reflected the real world. And he applied those principles and kind of talks about what happens when you model software teams like these queues and how should you best manage the work they're receiving. And he had a lot of insights, but two that I think are most important for this talk: don't saturate capacity, and that your batch size matters. So like I said, he models software teams as these MM1 queues. Work arrives in kind of a stochastic way. Most of it gets processed quickly, but there is a long tail on the distribution, so some stuff can take, it's possible for stuff to take a long time. One property of these queues is when you give them 100% of everything that they can do all at once, they just seize up. They just stop being able to really do work. And really there's a sweet spot at around 75% utilization that you really start to see throughput tank. You also see variability go through the roof, so stuff that seems like it should be done very quickly suddenly takes a really long time for no reason. I don't know if people have experienced that on teams as well. I know I have. So for Reinertsen, it's not just a culture thing or a safety thing of why you should prevent overload, keep teams out of overload. There's also a pretty strong economic case, like your teams will just perform poorly when they're really overworked. The other thing, since this is an SRE crowd, one of the things I took away from the conference here is that teams have very different levels of interrupt from company to company. But if you are one of those high interrupt teams, that should get factored in before you start, before you figure out what you're going to pull in. And the real thing here, I guess, to say is that when you on your team are pulling in work, whether it's for the sprint or the quarter or whatever, when you're saying, yeah, we can take this on, I think it's important to call out that it's not just upside risk to pull in too much. It's not like, oh, hey, we accidentally did 50% more than we thought we could, that there is a mathematical downside fixed cost as you pull more and more stuff in. And if Reinertsen doesn't like, oh man, I'm way ahead of time here. I guess we're gonna get to see extra slides. This is great. So if he hates overutilized team, he really hates these large batches of work. Large batches of work. So let's say you get word from above that the company needs to switch its identity provider for whatever reason, and that's going to be a big project that has a bunch of different dependencies and a bunch of different environments, and it's going to hit a bunch of different teams. But you're kind of overworked. You think, okay, well, we kind of know what that is. We'll just work on it as we go. We'll just leave it as kind of this big hunk of work on our board. Well, what happens then? Well, the size in these Reinertsen-esque queues, I should say, size has an exponential relationship with delivery time. So incrementally, as you get bigger, it takes you a lot longer. The variability we're talking about also goes up, where things just seem to take longer for no reason. The most interesting property here that I found was that these big batches of work are really self-reinforcing. So I mentioned the 10 other teams that all have dependencies here. Because you have a big block of work on your board, things tend to agglomerate and back up and become big on all of their boards, and that kind of self-propagates out, all throughout your organization. Let's just skip ahead. Hold on. See, I said extra slides. So the other thing that Reinertsen talks about is WIP limits. I am not a work in progress limits. How much work does your team have in flight at once? There are a lot of different ways of thinking about WIP limits. I'm not a big evangelist of any. I think for Reinertsen, the thing that WIP limits give you is they help with what you might think of as your 1% lows. So like that stuff that takes a really long time for no real reason, WIP limits can really help with that. And for these mathematical queues, it's like twice your average WIP level is where you should set the limit. If you're a theory of constraints person, you find the biggest bottleneck and you set a global rate limit to that. If you're a utilization trap person, you want fewer tasks than you have servers or actors. So if that's another case for pair programming and things like that. And the Agile folks, they just say, well, do what works. Figure it, like test, try things out, change things, nothing's fixed. So WIP limits are also talked about in the book as a strategy for combating some elements of this state of overload. There's also organizational WIP. This is a diagram from John Cutler's blog that I really like. I have this as a Zoom background when I'm sometimes feeling too snarky. And the way you read this here is kind of in the center left there is, you see WIP is rising, work in progress is rising, organization right. We'll follow your choice of arrow to see kind of what this mind map of kind of what happens there. Throughput goes down. It takes us longer to learn. We lose morale. We miss deadlines. Then we have to hire new people quickly, and it kind of all feeds back around into WIP. And the thing that I like about this diagram is you can really imagine some awesome heroic interventions that might fit, that someone might attempt. So like, if you have a really good manager, they might sacrifice a bunch of political capital and really block their team for that pressure from short-term results, right? Or you might have an engineer that's like, I'm just gonna work through this all weekend long and I'm gonna make sure that time to deliver does not go up. But because this is a big web, you can see that these pressures will find other ways back through the system, that these sort of short-term intervention circuit breakers don't really have a permanent impact. And the other interesting thing about this diagram to me is that, like, if you look over here, like rapidly hiring new players, well, that looks like a response of recruiting resources, shedding, just not doing as much or doing things more quickly. You can kind of map on, like, a whole organization can be in this state of overload as well, and you'd see sort of these responses manifesting at that level as well. So that's what I got. Yeah, thank you so much.